Hello and welcome to activity 4. In this activity we are going to be adding and subtracting polynomials, and in our first lesson we are going to be learning some polynomial terminology. So our first learning target is going to be to identify parts of a polynomial, and our second learning target is to identify the degree of a polynomial. So we start with an application about solar panels. You might have seen these on roofs of houses. A solar panel is a device that collects and converts solar energy into electricity or heat. The solar panel consists of interconnected solar cells. The panels can have different numbers of solar cells and can come in either square or rectangular shapes. How many solar cells are in the panel below? Well, I can see it's 4 by 4, so that would be 16. Okay. Now, if a solar panel has 4 rows, but has an unknown number of columns, x, well then we can write that as 4 times x, just like we had written 4 times 4 to get 16. Now, if their expression had unknown rows and unknown columns, we could go x times x or write it as x squared. Now, if there were 5 of those panels, we could write it as 5 times x squared. All of the answers in items 1 through 4 are called terms. A term is a number, variable, or the product of a number and variables. So we can write the expression to represent a sum of our answers, and if we write it in the correct order, which is descending, we'll start with 5x squared plus our 4x term plus our constant 16. So these are all terminology that we are going to be learning in this lesson. Page 2, it says expressions like the answer to number 5 are called polynomials. A polynomial is a single term or the sum of 2 or more terms with whole number powers. Okay, so you need whole number powers to be considered a polynomial. So if I list the terms from the polynomial I wrote in item 5, I wrote a term of 5x squared, a term of 4x, and a constant of 16, which is also a term. And then we had put them together with addition signs, and that made it an expression. So the coefficients then would be considered 5 and 4. Okay, those are my coefficients. And then I call the constant term 16. Okay, so a coefficient is the numeric factor of a term. And the constant term contains only a number, such as the answer to item 1. The constant term of a polynomial is a term of degree 0. So, technically we could write this as 16x to the 0 power, and it would be still equivalent to 16. Okay. Now, in the check your understanding box, they want us to tell whether each expression is a polynomial. So if I look at A, I have 3x to the negative 2 minus 5. So we have some terms there, but remember, we have to have whole number powers. And so that negative 1/2 means no, that it's not a polynomial, because that's not a whole number. However, part B, I can see 6x to the first and 4x squared. That is a polynomial. Part C, I can see 15. It could be written as 15x to the 0. 0 is a whole number, so a constant is also considered a polynomial. And then we get to part D with this power of 1/2. That is not a whole number, so that is not considered a polynomial. Okay, so for the expressions that are polynomials, we can identify the terms. So like in B, the terms are 6x and 4x squared. The coefficients are 6 and 4. And there really is no constant term there, or we could say it's 0. And then for part C, we only have a constant term, 15. So technically, we don't really call 15 a coefficient, but it could be considered one if it was 15x to the 0 power. Okay, in the next part of our lesson, we're going to start talking about the degree of a polynomial. Okay, so we'll start with the degree of a term. And the degree of the term is the sum of the exponents of the variable contained in the term. So in our first polynomial, all of the terms have just one variable, so it's pretty easy to pick out the exponent. Okay, so like in the first expression, 4x to the 5th, the degree is 5, and the coefficient is 4. 12x squared, the degree would be 3, and the coefficient 12. 1x squared, degree is 2, coefficient is 1, and negative x, degree is 1, and coefficient is negative 1. So when there's one variable, it's not too hard to do. But in the next polynomial, you're going to see many terms with different variables. Okay, so I'm going to pick out a couple of those terms to write out. Let's take the first one. The first one is 2x to the third y. So if I wanted to get the degree, I would have to actually add the powers of the variables. So it's 3 plus 1, which would be 4. Okay, and then the coefficient is going to be 2. And let me pick a different term. I'll go into the third term. How about the 9xy? So for the 9xy, the degree is going to be 1 plus 1, 2. And the coefficient will be 9. Let's pick the 15 because that's a little different. That's the constant. So for that term, the degree would be 0 because we don't see it, but there could be an x to the 0 with that 15. Okay. And then the coefficient would also be 15 because it would be like 15x to the 0. Okay, and there's a couple other terms, but that gives you the idea. All right, on the next page, page 3, we're going to talk about the degree of the entire polynomial now. And so when we get to talking about the degree of a polynomial, it's going to be the greatest degree of any term of the polynomial. Okay, so like if we were to take the first example, we can see that 2x squared is the term with the highest power. And so 2 is the degree of the polynomial. And then, of course, the constant would be 7. In the second expression, we can see that 3 is the highest power. Okay, and coefficient this time is negative 3. And even though it's written backwards, we have an x squared, so that means the degree is 2, and the constant is 36. Okay. So now we're going to talk about the form of a polynomial. We call it standard form because we want the terms written in descending order of degree. So we do pay attention to degree for that reason. Okay, and then we talk about the leading coefficient as the coefficient of a polynomial's leading term when the polynomial is written in standard form. So here's a good example of standard form. 7x to the 5th plus 2x squared minus 3. And the lead coefficient would be considered the 7 because the highest power is 5. That's the leading term. We have 3 terms in this polynomial, and the terms are written in descending order according to power. Okay. We do have some special classifications for polynomials. For example, our first one, a monomial, is any polynomial that has just one term. Like it could be a constant 8 or negative 2x or 3x squared. A binomial would be any polynomial that has 2 terms, like maybe 3x plus 2 or 4x squared minus 7x. Okay. A trinomial, just like it sounds, would have 3 terms, such as this one here, negative x squared minus 3x plus 9. And for every other polynomial, you would just have a name of polynomial, whether it's 4 terms, 5 terms, 6 terms, we just call it a polynomial. And the others are also called polynomials. They say at the bottom, the number of terms for a general polynomial is greater than 0. Monomials, binomials, and trinomials are also all considered polynomials, but have a specified number of terms. Okay, a couple things on the side that I'll note. Descending order. Okay, descending order of degree means that the term has the highest degree written first, the term with the next highest degree is written next, and so on. And then also just some of the language, the prefixes. Mono means 1, bi means 2, tri is 3, and poly means many. You'll see these terms all throughout mathematics, such as bisect, which means cut in half, or triangle, which means 3-sided figure, and polygon, which means a many-sided figure. So that's really just an introduction to polynomials, and I'm going to ask you to complete problems 13 through 23 for your homework, and feel free to ask questions in class, and also check the PDF that's filled in to check some of your answers. Thanks, everybody. Have a great day.